Okay, so lecture 1, 2, 3, 4, we're done with those. We're picking up on lecture 5. Last one before our first test. Okay, so lecture 5 is dealing with complex numbers. Someone give me an example. Define for me the natural numbers. What are the natural numbers?
Things on the number line.
It's like the regular ones, like 1, 2, 3.
So counting numbers you use to count. 1, 2, 3. Okay, what are the integers then?
Negative or
-2.
Same set natural, except now we add the negatives. So we have -2, -1, 0, 1, and 2. Okay? So then we get bigger to rationals. And what do the rationals start to include?
The 0?
Zero's already
Yes.
integers.
Fractions.
What'd you say?
I said decimals prefer.
Okay, so we get fractions and decimals. So like 1/2, 0.7, anything to be written as a fraction. Okay, in fact, we could do something like P over Q. Okay, anything to be written as a fraction. So then what's irrational?
Oh, three repeat.
No, because repeating would be here, like 1/3
Oh, wait, are you
would be
talking about?
0.3 repeating, so repeating decimals are over here.
Okay.
What are irrational?
The ones that don't have a pattern.
Say it again.
The ones that don't have a pattern in them.
Okay, ones
Or
that
like-
don't have a pattern or end, they don't repeat or end. So if a rational is a number that can be written as a fraction, irrational are numbers that
Can't.
cannot be written as fractions. So that would be things like pi, radical 2, things like that. E, we gave you those examples before, I believe. Now, everything in this box are real numbers, and they can all be put on a number line. Okay, when you started first learning numbers, everything you learned was real numbers. And then in algebra 2, probably we will introduce you to complex numbers. What are complex numbers? Okay, now we include the imaginary. And actually, this should just be imaginary. So I, the square root of -1. Okay. And we write complex numbers as A plus BI. And really, complex refers to both boxes, because I can write a real number as a complex. The A is just the real part of it. The B is the imaginary. Okay, so we know that I is the square root of -1. So there's several different problem types with radical or with i's. Things like, let's do Roman numeral 1. Roman numeral 1, and that is operations with i's. So like if I was going to do something with addition, something like, let's say 4 plus 2i plus 3 minus 6i. Okay. We have that imaginary part of the number, we have the real part of the number. How do I add imaginary numbers?
Combine like terms.
It's just like if it was an x. Just combine like terms. 4 plus 3 gives me 7. 2i minus 6i gives me -4i. It really is just combining like terms. Remember that from last year? We haven't covered that this year yet, right? Okay, because I think I did in my other class. So does this make sense? Just combine like terms. Remember this? Remember this? If no, yell at me. Okay.
Question. So in algebra 2, the i's were like talked about like 7. I remember there's something being with like 7 and I2 is like some other number. Am I just making that up in my head?
Hang on, maybe we'll get to that in a minute.
Okay, sorry.
Part B, that's okay. Part B is like if we have subtraction. So same type of problem if I have 4 plus 2i minus 3 minus 6i. I saw this mistake over and over in pre-calc. Please make sure we distribute that negative sign, right? Just like combining like terms, nothing new here. Okay? Distribute. So you have 4 plus 2i minus 3 plus 6i. And then just combine. 4 minus 3 is 1. 2i and 6i is plus 8i. So once again, nothing new yet. Okay. Good so far? Now comes, this might be what you're referring to. I'm going to put a little note in here. And I'm going to go to the next page and expound on it. Little big word. So we know that I equals the square root of -1. Okay. What does I squared be equal to?
It's -1.
-1, because it's simply going to be the square root of -1 times the square root of -1, which is simply -1. So whenever I see I squared, -1 goes in its place. What if I give you I to the third? What's that going to be? 1. Not 1.
Oh.
You got it?
Was that where the 7
That's over 7.
Oh, we learned this. 1. Or wait, I'm tripping.
Okay, so here we go.
We learned this
It
last
means
year, I
the
forgot.
square root of -1 times the square root of -1 times the square root of -1, right? What does the square root of -1 and the square root of -1 equal?
1 is -1.
-1. I squared equals -1. And what is the square root of -1? I. So it equals
Oh, I
negative
remember
I.
this. Yeah. We have a whole sheet.
You know, whole sheet on. Now, the one you're all waiting for, what does I to the fourth equal?
Is that the 7?
Say it again.
Is that the 7?
That's not the 7.
Oh.
What'd you say?
1.
1. Because it's the square root of -1 times the square root of -1 4 times, which is going to be -1 times -1, which equals positive. So you probably had this little cheat sheet last year. It said I is the square root of -1, I squared equals -1, I cubed equals I to the fourth equals 1. Probably had a little cheat sheet like that. Yes? I thought you said a question.
No.
Okay. Now, let's keep the thing going. What happens when I get I to the fifth?
I do it yes.
Say it again.
1
Yes. It's just a square root of -1, it's just I. Because it's like saying I to the fourth times I, which is 1 times I, which is just I.
So then, if you can get a number, why do you write out I? Because we can get the
Square root of -1.
Okay.
And we don't want to write the square root of -1. It's ugly.
Okay.
Do you know why, honestly? And here's the legitimate reason why we write I rather than the square root of -1. Why? Why do we do that? Anyone know? Okay. Mathematicians are inherently lazy. Okay? This is 2 pen strokes. This is 1, 2, 3. That's really why we do the I, because it's just faster. Fewer pen strokes and a dot.
But how? Okay, so if I can get a -1, if I can get a +1 when I3 and I4 are written out, why don't you just replace I3 and I4 by 1 and -1?
You will. You'll
Okay.
replace. This is what you're going to write. This is what you're going to write on this side. Whenever you see I squared, you're going to write -1.
Okay.
Whenever you see I to the fourth, you're going to write 1.
Okay.
Whenever you see square root of -1, you're going to write 9. Those are the preferred terms.
Okay.
But let's keep going with our little notation here. What is I to the 6th? Well, it's the same thing as I squared. What's I to the 7th? Same thing as I to the 3rd. I to the 8th? Same thing as I. So really, you just have to figure out where the power is going to land, right? So do you remember this? I have never seen an application of this, but I've seen it on ACT tests. How many of you have taken the ACT already? How many of you are going to take the ACT in the future? Okay, so this is always on the ACT, but I don't know why. I've seen it on so many. Maybe it's not in the new ones. Okay, but they'll give you something like I to the 473rd power. Say, what's the answer? Well, it's going to be one of these 4 answers. So they're going to be I, -1, -I, or I. It's going to be one of those 4. In fact, it's an odd number, so it's either going to be I or -I. So the question is, where does it land? 1, 2, 3, 4, 5, 6, 7. You just count it out. Or we could take 473 and divide by 4, because it has a pattern of 4, right? It's just gonna go over and over and over. Just gotta figure out where it lands. Okay? So one, okay, correct. So we get 3, 3, 8, 32 with a remainder of 1. So that's what you have to know, remainder of 1. So it's gonna land right there. So the answer is gonna be just I. So you simply take the exponent, divide by 4, figure out what the remainder is, where's it gonna land, and done. All right, so that's just kind of the plus for ACT. If you need help with that, ask me. I'm probably not going to test you over that. That's just a little number sense question they usually ask. But the key here is we know that I squared equals -1. So let's go back to our notes. We had, first one was add, second one was subtract. So I think we're on letter C, multiplying. Okay, this is the one that's important when it comes to i's. Okay, if I give you something like 2 plus 3i times 4 plus 5i. Now when I added and subtracted rational or imaginary, I simply combine like terms. How would I do this if this was 2 plus 3x and 4 plus 5x? What would I do? FOIL, right? We're going to do the same thing. We're going to do 2 times 4 gives me 8. 2 times 5i is plus 10i. 3i times 4 is plus 12i. 3i times 5 is going to give me plus 15i squared. And there's my problem, and that's going to be my new thing with this one. It's the only thing that's different. Okay, I have that I squared. And what do I replace that I squared with?
-1.
-1. So I'm going to have 8 plus 10i plus 12i gives me 22i plus 15 times -1. So then you can simplify, you get -7 plus 22.
Wait.
Multiply 15 times -1.
Oh,
and then
so you
combine.
multiply it, okay.
So you get 8 minus 15, -7. So there's no difference from this one we did earlier with polynomials, except that right there. Whenever you see I squared, you put it in there. How many of you have seen that before? The rest of you, it's brand new. You ever seen that before?
I think you talked about it in algebra too.
Yes, we definitely cover it. So, yep. You didn't raise your hand. Have you seen it before? It's been a while. All right, I want you to try one on your own. It's the only difference there, and then I want to get into some division. Okay? So that's where I kind of want to spend the bulk of the time. So you try this right now. Let's go with 3 minus 4i, and let's go with 2 plus 3i. Try that one. Do we need something? Do I need to go back? We good? Okay. Give that one a try.
You didn't get that on recording?
Maybe I did, I don't know. I can't tell what it's doing. Okay, so let's look at the last one then, division. Okay? So this is part D, division of complex numbers. Now, really we're not dividing. We're simply going to change its form. And actually, it's kind of an old thing called rationalizing the denominator. Back in olden times, you know, back when math was just beginning to be discovered when I was in high school,
Oh.
That's a joke, I'm not that old. We didn't like anything in the denominator except rational numbers. Because you couldn't divide by things that were, today we have calculators, we have computers, we can rationalize, we can divide by anything. But back in the day, you couldn't. You had to have a rational number in the denominator. So with an I down there, we don't have rational, we have a complex number. So our goal with division is to make the denominator rational. I should put a Q there. Q. Make the denominator a rational number. Okay? So that's my goal. So we're going to do it. Here's a little note. Another little note in our notes. We're going to use what's called a conjugate. How many of you in English class have conjugated verbs? Do you know what I mean? Do they still conjugate verbs in grammar?
Yes, like wasn't.
We just do it though, I don't think we like.
Yeah, I think that's like third
We just kind
grade
of do
doing
it, yeah.
What do you do then?
Like
Put them together.
you could not, could then the in.
That's a contraction.
Wait.
Conjugate. Conjugate a verb. Anyone know what that means?
We probably know it, but just don't remember.
We probably
the
know it, but we
program.
don't call it that. I
I've
think
said
we
this
just-
for years, and I
I
could be
think
completely
We
wrong.
just do it.
I remember from high school, I thought conjugating verbs was like ran, run, will run,
Oh, that's
fly,
that's
flew, will fly. Conjugating verbs.
that's
I could be wrong.
I was like, we do that, we don't call it that though. We
Okay,
just do it.
so we're going to do the conjugate in math. Okay, so if I give you, we can do this with irrational numbers like radicals, or we're going to do it in this case with i's. So if I give you something like 4 plus 2i, something like that, the conjugate is simply going to be, we're going to change the sign of the imaginary part. So rather than 4 plus 2i, I have 4 minus 2i. If I give you 6 minus 3i, its conjugate would be what?
6 plus
6 plus 3i. Very good. 6 plus. You're simply changing the sign of the conjugate. Now the question is,
How does-
Oh yeah, why?
why?
Yeah, how does that help?
Well, how well does it help? Well, let's look and see what happens. Let's take 4 plus 2i, and let's do what we just did with multiplying, and multiply by its conjugate. Okay? Let's take 4 plus 2i times 4 minus 2i. Okay, so what's 4 times 4?
16.
Outstanding. What's 4 times negative 2i?
Negative 8i.
Negative 8i. What is 2i times 4?
8i.
Positive 8i. What's going to happen to those two?
Cancel out.
They're going to cancel. They're going to go away, right? Negative 8i plus 8i is 0. What is 2i times a negative 2i?
4.
I squared.
Negative 4i
Which
squared.
is just regular 4.
And what happens to i squared?
Flips. It flips to positive.
Becomes a negative, right?
Yeah.
The i squared becomes a negative. So it goes away. These cancel, and you have 16 plus 4, which is 20. I've gotten rid of the I.
Oh, okay.
So what it's going to do by multiplying by the conjugate is, now, you guys have seen this before too, okay? And something else. Let's look at, do you remember back when we factored? I'm going to switch sheet. Remember when we factored x squared minus 4? What does that factor to?
The x plus 4, x minus 4.
X minus.
X minus 2, x plus 2, right?
Oh, yeah.
They're conjugates. All I did was change sign. And you get rid of that middle term. Okay, so it's the same concept as the difference of two squares. These are conjugates, just like with our imaginary numbers, these are conjugates. You just change the sign of the middle term. And then that gets rid of all the i's. Same thing will happen with radicals. Okay, so to divide, our rule is simply going to be multiply both numerator and denominator by the conjugate. Now, what do you think? The conjugate of, which one do you think we want to get rid of? The numerator or the denominator?
Denominator.
Denominator. So we're multiplying the conjugate of the denominator. Okay, and that's how we do it. You multiply both the numerator and the denominator by the conjugate of, I don't care what the numerator is. Numerator can be anything. It can be rational, irrational, complex, it can be anything. It's my denominator that gives us this problem. Okay? So we're simply going to take the conjugate of the denominator multiply that top and bottom, and we're done. Yes?
Wait, so where's the denominator on like 4 plus 2i?
There's not, I was just showing you
Oh.
examples of
Oops,
conjugates.
my bad.
No, you're fine. That's just how we find conjugates. Okay. So let's give you one. Are we good? Example. So let's actually write a function here. Let's say 2 plus 3i over 3 minus 7i. Okay. Now the issue is, are you off to Longview? Yeah, okay. Have a great afternoon. I am recording this, so, but this is the last part. Okay. All right, so I'm going to go ahead and take the conjugate of the denominator, which is what? Take the denominator. What's its conjugate?
3 plus 7i.
3 plus 7i. So I'm going to take the bottom and multiply by 3 plus 7i, and I'm going to take the top and multiply by 3 plus 7i. Because I'm really just multiplying by 1. Okay, remember when I moved whatever the numerator down is the same, that's just a value of 1. So I'm not really changing the value of this fraction, I'm just changing the way it looks. It's like when I had 1/2, if I multiply the top and bottom by 4, I get 4 over 8. I'm changing the way it looks, not its value. So I'm not changing its value, just the way it looks. So then we have to go ahead and just multiply everything out. Okay. So the top is going to be, let's see here, let's change colors. I'm bored with this. 2 times 3 gives me 6 plus 14i plus 9i plus 21i squared, which becomes what?
Well, that goes to negative, and then you combine the other two.
So 6 minus 21 gives me negative 15. 14i, 9i gives me plus 23i.
And then the bottom.
Now on bottom, since I'm multiplying by the conjugate, I know the middle 2 are going to cancel, correct? Okay. So if you want to do save a little time, when it comes to FOIL, all you got to do is first and last. Because the outside and the inside, the OI are going to cancel each other out. So if I do 3 times 3, that's going to give me 9. I know that's going to be positive and negative 21. So then I have negative 49i squared.
Which is just regular 49. So
Which is just
58.
plus 49. So you should come up with 58.
So it's not the last step we're done?
Well, yeah, I'm going to show you something different in a second, but yeah, that's pretty much done. Okay, questions on the conjugate, on multiplying, anything like that? Okay, now, when you get to delta math, when you get to possibly my test, you might see it look a little different. I don't want you to freak out when you see it, okay? Especially ACT. ACT is the same thing. I like the way it's written here. For me, this is fine. If it's a constructed response, you're perfectly fine. However, you might see it different on delta math, and they might require it differently. Okay? What they're going to do is they're going to split this up. They're going to make it negative 15 over 58 plus 23i over 58. And they may want you to write it like that.
That's just strange.
Okay. Well, actually, this is probably more mathematically accurate because we wanted the term a plus bi. So we know that this is a plus and this is b. So probably more accurate, but either way is fine with me. All right. Anyone need to see another example? You want to try one on your own? You ready for homework? Give me a 1, 2, 3, 4, 5.
Wait, so which one's the try one on our own?
I'll put one up here if I want 2. Okay. I'll put a problem on the board for those of you who want to try it. Those of you who are ready, homework is out there ready to go. But I'll put one on the board and we'll go over if you need to. Okay? And there was a couple of you, so perfectly fine.
Was there a new delta math?
Yep. 1 plus 4i over, let me do one on my notes. 5 minus. Yeah, if you want to try, give that one a try.